Let's come to section 2.8, higher derivative. So again, we're asked to find the second derivative. We're given a function this time that isn't a polynomial. It actually has a square root in it. I personally prefer exponents to radicals, so I'll say 17x cubed plus 5x to the 1/2. So the first derivative of that, just say that's 51x squared plus 5 over 2x to the negative half. The next derivative, 102x minus 5 over 4x to the negative 3 over 2. Notice that even if I did the third, fourth, fifth, sixth, seventh, eighth, ninth, 10th derivative of this one, I'm not going to end up with a constant in the same way I did with a plain old polynomial. Polynomials, they drop in degree by 1 because of that power rule when we differentiate. This one, the degree is dropping by 1, but because we started with a fraction, it goes from positive a half to negative a half to negative 3 halves to negative 5 halves to negative 7 halves. So we'll never get rid of it. I should probably take a second to practice factoring this a little bit better. I would probably take out a quarter. I would also take out x to the negative 3 over 2. So maybe let's start with that as a common factor. What does that leave us with? Well, this first term here, we need to divide it by a quarter. So we're going to have 408, and we're going to have x to the power of 5 over 2. Minus, we already took out the quarter, so we just have 5, and we already took out the x to the negative 3 over 2. Possibly even better than that, negative exponents aren't really great to leave in our final answers. You won't find those in the answers in the back of the book, so you probably would be more likely to see something like this. And that would be kind of your more simplified, better version of that second derivative. In the second example here, we're asked to find f prime prime of 2. So in other words, the value of the second derivative when x equals 2, if f of x is this 7 minus x cubed function. So the first derivative, I require the chain rule to say 3 times this squared times the derivative of the inside. And I could write that as negative 3 times 7 minus x squared. The next derivative of that is going to be 2 times negative 3, so negative 6, 7 minus x to the 1 times negative 1. So positive 6 times 7 minus x. Could multiply it out, but really a simplified version doesn't matter because what I'm supposed to do is put in a 2 here. Instead of prime prime of 2, it's going to be 6 times 7 minus 2, which is 30. We did describe in our when we learned the first derivative that it was the slope of a tangent line to a graph or instantaneous rate of change. Second derivatives and higher is a little harder to picture, but it will turn out to be very useful to us when we get especially to curve sketching. It'll tell us something about the curvature of the graph, which is useful. So right now, imagining it as the rate of change probably doesn't help you that much, but you have to trust me, I suppose, when I say that second derivatives and higher will actually be useful to us.